You kept track of your compass and kept it from breaking so far this year? They have them at the office. They're $1. Okay, so if you gotta have one. I think I might have some parts. Like I found that on the floor. So if someone's missing that, maybe you can borrow that or take that from me. Okay, so we're going to start talking about concurrent points in triangles and their relationship with triangles this chapter. So we need to know what concurrent means. All right, so why don't you go ahead and just write that word down on your paper, way up at the top. Concurrent lines, rays, segments. That's when 3 or more lines, rays, or segments intersect at a single point. So it has to be 3 or more. Three or more points, lines, or planes. Or sorry, points, lines, or rays. So I drew a line, I drew a segment, I drew a ray, and they all intersect at this single point, which is called the point of concurrency. For most of our purposes in this class, we're going to be looking at where lines intersect, but it really doesn't matter if they're lines, segments, rays. As long as there's 3 or more and they intersect at a single point, they're called concurrent, and that point is called the point of concurrency. Okay, so now I'm going to show you a particular point of concurrency in a triangle, and we're going to talk about it. So I wanted to just do this full thing for you while you're all watching, so you know I'm not just tricking you. So I'm going to do my best to make this as neat as I possibly can. So I'm just going to draw a triangle, okay? And I'm going to start off with, we'll do an acute triangle. Now this changes if it's a different type of triangle. There's some changes, differences, but we'll talk about those here in a minute. So here I just have a triangle. There's nothing really special about it. And what we're going to do is we're going to draw in some perpendicular bisectors. So I'm going to construct the perpendicular bisector of AC. Y'all okay with that? Okay, so I'll do that. I'll do that one in red so you can see what's going on. So this is something you're going to have to be able to do yourself. So remember, I just make sure I'm more than halfway to C, and I can just make the arc, and then I can come over here. Same arc, right? Like that. Can you see that okay? I made it really light because I don't want to too much. And I'm just going to draw this in. And it is the perpendicular bisector of AC. You okay with that? I'm move it up a little bit. Okay. Now I'm going to draw the perpendicular bisector of another side, so AB. Okay. So I'll do this one in blue so I can keep track of what's going on here. You guys have the pencils. You can erase your arcs as you do the problem, and that should make life better for you. But I can't erase this, so more than halfway. Now, you know how I had it? See how I had it right there already when I was doing the arc down here for AC? I'm actually going to leave. I think I'll do this in red still. I'm just going to use that same arc that I was using before, and I'm just going to extend it around some more. So I didn't adjust my compass. I just extended it around further. And then I'm going to leave my compass set the same way. And I'm going to come over here to point B. And I'll just extend that one. So now can we see the perpendicular bisector of AB? Yeah. Okay. So I can draw that in. Okay. Now I want you to notice these two perpendicular bisectors intersect right there, right? Are they concurrent then? Yeah, good. Yeah, they have to have three. I have to have three of them, right? Well, are we done? Wouldn't it be weird if the other perpendicular bisector went through that same point? What do you think?
Yes, but I know it's going to.
Oh, you know it's going to. Okay. So I'm just going to leave my compass set exactly the same way. And I'm going to come over here. Now, I guess I could have done this in the first place. I'm just going to extend that around. And then I'll come up at point B. And I'll just bring that one. Uh-oh. Now, do you see my problem here? What was the problem? Yeah?
So that side is longer than all the other ones, so having your compass in isn't...
Exactly. My compass, it has to be set more than halfway, doesn't it? So, okay. Now you can solve that problem by just making sure to do the longest side first. Okay, and then it'll work. But we're gonna have to extend our compass out here, make an arc. But now I should be able to draw this other perpendicular bisector in. So there's the other perpendicular bisector. And are the three perpendicular bisectors concurrent? They're concurrent, aren't they? Okay. So I think that's kind of amazing. So there's our point of concurrency right there. And it actually has a name. When the perpendicular bisectors intersect in a triangle like this, and they have a point of concurrency, this particular point of concurrency is called the circumcenter. Okay? Now, you have to know that. You have to know that the circumcenter is the point of concurrency when we draw the perpendicular bisectors of a triangle. That's a lot. That's a lot, isn't it? But you're going to have it in your notes on this paper. You're going to have an example of it, and you can use this on the test, okay, to help you remember what the circumcenter is, because we're going to talk about quite a few, 4 or 5. So now there's a reason it's called the circumcenter. You guys ever heard of a circumscribe something? Put a circle around it. Okay. This circumcenter happens to be equidistant from the end points of the triangle, from the vertices of the triangle. That point right there, we'll just call it point P, point of concurrency. That point, the distance from that point to A, and from that point to B, and from that point to C, those three distances are all congruent. And I can actually show you that they're all congruent. Check this out. Don't take notes right now. Watch. So I'm saying that distance there and this distance here, let me see if I can get it. It's really hard to get it just perfect. I think we're pretty good. So all three of those are actually radii of that circle. I think I got my pen bent a little weird here. So they're all three. There we go. There we go. Equidistant from this point. And that's why it's called the circumcenter, is because from that point you can circumscribe the triangle. Okay? Now, this happens in an acute triangle. I just drew an acute triangle. It happened, didn't it? Okay. If I drew a different acute triangle, would it still work?
Yeah.
What if I drew a right triangle? Think it would work?
Yeah.
Absolutely works. Okay. But this point of concurrency is on the interior of the triangle. Okay. If we did a right triangle, the point of concurrency would not be right on the interior of the triangle. It would actually be right here on the midpoint of the hypotenuse. It ends up right there. So if you draw the perpendicular bisector in of this one, and you draw the perpendicular bisector of this one, and you draw the perpendicular bisector of this side here, okay, they all intersect right at the midpoint of the hypotenuse. And that'll happen every time, and then you can still circumscribe the circle using that as the point of the center of the circle. If it's an obtuse triangle, and we draw the perpendicular bisector in of each side, so I'll do all three of these. So here's one. Here's a perpendicular bisector. There's a perpendicular bisector. And I just eyeballed those. I didn't construct them. But they will be concurrent. That will be the circumcenter, and that point will be equidistant from the endpoints of the triangle. And you'll still be able to circumscribe the triangle from that point. And even though I eyeballed that, and it's a pretty bad example, I still want to show you that it's close. Okay? So, you need to give this a shot. So, what I'd like you to do is do the obtuse triangle. But I just have to tell you, the more obtuse you make it, so if you make it really obtuse, the intersection of the perpendicular bisectors gets further and further and further from the center of the triangle. And it gets harder and harder and harder to construct, okay? So I want you to draw a big triangle like this. See how big that is? Okay? And I want you to make it obtuse, but don't get too carried away. Just make it 100 degrees or 110 degrees, something like that. And then I want you to construct the three perpendicular bisectors and see if we can get those to be concurrent, and then circumscribe the triangle.